ये तो क्या ये उसके सामने डाल उसके सामने डाल
Pradyum Mohta, mute yourself. Instead of let them come in, let me tell you about one thing. Yesterday it was decided that second year when you enter, see every year some mentors are allocated. Okay, since last year there was a problem, that's why no mentor was allocated to your batch. And first year also they don't have any mentor. Otherwise, third year and fourth year they have mentors. So yesterday it was planned that second year's mentors are, there are two mentors, okay? Rajiv sir, I don't know, you all know him, he takes your class. RJB sir,
Yes, ma'am.
he takes your class. Okay, so RJB sir and me are the mentors of this second year batch. Okay, what you have to do is, all of you listen carefully, what you have to do is, there is 100 marks for some external, extracurricular activities. Okay, what you have to do is, under extracurricular activities, there are, you can attend courses. You have to attend such courses where examination system is there. Means they give a certificate and you give an exam. For example, NPTEL is a good one. You find out courses which you are interested in and attend those courses. Whatever certificate you will get, you have to mail it to me and sir. See, one of the group, maybe group one, I will look after, and group two, sir will look after. Okay, so not only courses, you can attend any. See, forget about Corona event. I'm telling, if everything was normal, then what are the external or extracurricular activities? We gave points on tree plantation. Keep these in mind, because later on you have to do all these things. Tree plantation. Then if you arrange any, if you are event manager, means if you are arranging any event like suppose cultural fest or blood donation camp, these are, if you arrange them, then you get some marks. If you do blood donation and if you attend the blood donation camp and give blood, donate blood, then also there are some marks. Okay. Next, if you there's a chart, I will send you that. There it is clearly mentioned what are the activities you can do. But since nowadays everything is online in this phase, so it would be better that you attend courses much more, because attending courses, there is lot of marks on attending courses. Okay, so go on attending courses, 2-3 courses, so that you can attend that 100 marks overall. This was for this semester. For previous years, like previous semester, then first year also, if you have done whatever you have done in that academic year, you will send me the certificates of those. Okay, first year, Corona was not there. It was not lockdown phase, isn't it? So first year, maybe first semester, you all.
Ma'am, it was there.
Oh, first semester.
No, in first semester it wasn't there.
Yes, so first semester maybe you have attended something. So you will, whatever you have with you, you will mail me. I will give you a date. Don't mail me now, because let us decide which group I am allocated. I will accordingly. I will ask you. This is just a roughly. I said that you, so that you can become alert that you have to do all these things. Okay. So from today onwards, we'll go through NPTEL. Then Coursera is also there. They also give certificates and they conduct exams. And after conducting exams, if you pass their exam, then they give you the certificates. So you can look after those courses in Coursera as well as in NPTEL. NPTEL courses are very good, but the examinations are little bit tough. Means you have to follow their course. It is not that you will just log in and you will not listen to their lectures. That will not work. If you are serious, you can attend NPTEL courses because the exams are not very easy. Okay.
Ma'am, you're not audible properly.
I'm not audible properly. I am speaking very
Sometimes,
low voice.
sometimes the voice is
The voice is stuttering actually. It's maybe due to some poor connection, ma'am.
Poor connection. Okay, let's see. Now, how many have joined? 49. Okay. So let me start. Share the screen. So today, everybody sit with your copy. Whatever I say, you will write in your copy and then I will explain what is the meaning. Am I audible now properly?
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Students are entering. Wait. Let me admit them. Okay. So give the heading super key, candidate key, and primary key. Primary key we have already known, but we will know it again in a different way, in a different manner. Okay. So super key. First topic is super key. We will know what is a super key. First, you write the definition of super key. Then I will explain what it is. A super key is a set of attributes. A super key is a set of attributes that uniquely identify each tuple of the relation. A super key is a set of attributes that uniquely identify each tuple of the relation. In other words, a super key distinguishes each tuple of the relation. Written? All of you have written. A super key is a set of attributes that uniquely identify each tuple of the relation. In other words, a super key is a set of attributes which distinguishes each tuple of the relation. Written, completed, writing?
Yes, ma'am.
Yes, ma'am.
Now, what it is? What is the meaning of this super key? What did I say? I said it is a set of attributes, isn't it? Suppose a relation R. There is a relation whose name is R. There is a table whose name is R. Okay. The table has 4 attributes. Suppose A is one of the attributes, B is the second attribute, C is the third attribute, and D is the fourth attribute. Now, if I say, just 1 minute. Yesterday I had wait. I have the table now. Wait, just let me find out yesterday's file. See, yesterday it is visible, isn't it? Yesterday we had a table called employee, isn't it? Now in the employee table, is there any attribute which uniquely identifies each tuple of the relation? What is the meaning of uniquely identifies each tuple of the relation? The meaning is the values of that attribute, if the values of that attribute are unique, then only I can say that due to that uniqueness, each tuple will become unique. Maybe the other columns of the tuple have duplicate values, But since a particular attribute or a set of attributes, if it is unique, then its uniqueness makes all the tuples unique or helps us to distinguish between the tuples. That means each tuples are different from the other tuple. Now, if you look here, do I have any attribute or attributes, combination attributes, which is unique in each row?
Name.
See, EMP ID is itself is
Name.
not unique. Name itself is, let me change it, wait. Because name is actually never a unique thing. So name is not unique. Salary will also be not unique, isn't it? Here, for this particular instance, it was unique. But generally, in general scenario, if you think it is not unique, so I have made duplicate values. Department is also not unique. Commission is also not unique. So no single attribute is unique in this instance of the table that I am showing you. Now, so what I have to do? I have to combine attributes, and if I have to check whether they are unique or not. So EMP ID name, is it unique? E1A, E2A, E2AA, E3 BCD, E1 ABD. So it is unique, isn't it? EMP ID, comma name. Let me write here. Oh, let me write it. See, multiple share if I do, can you see it? Can you see this document? No, isn't it? So one by one, I have to do the share. So here, EMP ID, comma name, EMP ID. All of you mute yourself. Everybody mute yourself. I'm sharing it once more. So what I will do is, here, instead of ABCD, since I have the table with me now, I will write the attribute name. So it is EMP ID. B is what? B is name. C is what? C is salary. And what is D? D is department. And I also have commission. So these are the attributes of the relation whose name is not R, whose name is now I have EMP or employee. Now we are trying to find out the super keys of this relation employee. I said super key is a set of attributes which uniquely determine. So the set of attributes should itself be unique. Then only it can uniquely identify all the tuples. So here we just now saw that EMP ID, comma, name, their combination value is unique. So I will say EMP ID, comma, name, their combined value is unique, hence it is a super key. Next, any other combination do I have unique? Do I have anything else unique?
And salary department.
EMPID department I can have. EMPID, comma, department is unique most probably. So EMPID department is also unique. So it is a super key, another super key. So when I write a set of super keys, I give a bracket and then write one by one, you write all the super keys. Okay. Next, what else I can have?
Salary department. Salary department.
I've changed the value. Okay, we can have salary department. Salary, comma, department. Next, what else I can have? Can I have EMPID name, salary? EMPID, comma name, comma salary. When EMPID name is unique, then whatever attributes I add on to that, it will become unique, isn't it? Since EMPID name is unique, combination is unique. So if I add whatever attributes I add, like salary, when I add it, it will be unique. So with the super key, with the like EMPID name is a super key. With that super key, if I add some other attributes, I also get another super key because it will be overall unique. Similarly, with EMPID name, if I add EMPID name, if I add department, it will also be unique. Just check it. Similarly, with EMPID name, if I add commission, then too it will be unique. Same way with EMPID department, if you go on adding attributes, it will be unique. Okay. Now the thing is, so you will get how many super keys? Many super keys you are getting in this particular instance, isn't it? So just remember, all of you write a line that a table can have more than one super key. A table can have more than one super key. At least one super key is there in a table. At least one super key is always there in a table. And that is which one? Can anybody tell me? Well, suppose there are no combination is also unique. Here the combinations are unique, isn't it? Suppose here I don't have combination is unique. So EMPID name, see E1A, E1A. So I'm not having EMPID name as the super key because they are duplicate. Now, similarly, if your data is such that you are not, none of the combination, either single attribute nor the combinations are unique. So you will not get a super key, but at least one super key is always there. Whatever your data is, whatever duplicacy is there in your data, at least one mandatory super key is always there, and that is which one?
Candidate key.
I did not speak about candidate key. I'm asking at least one super key is there always, whatever your data, you don't have to check. And suppose if everything is duplicate, here this row is no, you cannot form any combination which is unique. You're not getting any combination which is unique. But still I will say,
any key assigned by the database.
I did not get you. Just
Ma'am, is there any default key assigned by the database?
No,
like
no, no,
1,
no.
2, 3, 4?
No one can answer this? At least, or if you write in your copy, at least one super key is always there in the table, and that is you should have answered this.
The combination
Primary
of all
key.
Combination of,
all-
yes, who is answering?
all columns.
Combination of
The combination of
all the columns. Very good. Who answered?
Ayush Kumar, ma'am.
Very good. Combination of all the columns is always unique because this is a RDBMS. And what does RDBMS say? No full tuple cannot be, I cannot have a record which is totally similar to the other one. No duplicate tuples. The full tuple cannot be duplicate. Individual columns are duplicate, their combinations are duplicates, all right. But the full combination, if I combine all the attributes, then I form a tuple, isn't it? I cannot have E1, A300, D1 again, a D1 0.2 again. I cannot have a row like this because RDBMS doesn't allow this. RDBMS doesn't allow duplicate tuples. Here, so the combination of all the attributes has to be unique. That means at least one record is there which will differentiate, which will make these two tuples different. At least one value has to be there which will differentiate the two tuples. Hence, I will say that if your data set is such that you are not getting any super key, then you will say that the combination of all these attributes is the only super key present in your table. This is the only super key if you don't get any other super key. Here, okay, understood this one. Now let me change the data. Suppose EMP ID is my primary key. So I have E1, E2, E3, E4, and E5. Name is this, salary is D. Okay. Now tell me, what are the super keys? What are the super keys? EMP ID is itself unique. So what are the super keys? If this is the data present. Let me reduce my table. Suppose I don't have salary. I don't have commission. Now tell me what are the available super keys in your table. Who will answer?
Ma'am, total 4 super keys are there.
Tell me one by one.
Ma'am, first EMP ID itself,
Wait, EMP ID itself.
then
Next.
EMP ID name,
EMP ID.
combination of EMP ID and name.
So whichever attribute I combine with EMP ID, it will be unique because EMP ID itself is unique, isn't it? So EMP ID name, EMP ID department. Anything else?
All of those three.
So EMP ID name is now a super key, so I can come. So it is unique, means the combination is unique. Hence, I can combine other attribute with EMP ID name. So I can write EMP ID, comma name, comma department is another super key. What else? Anything else? Name department combination
Name and
AD1,
department.
AD2, AD1. Yes, it is also a super key. So name, comma, department. This is another super key. Anything else? Any other combination left? EMP ID department. So given. Okay. So these are the super keys that are present in this instance of the table. What is an instance? Instance here means that at a particular moment, this is the data that is present in your table. So that is known as the term that we use is this is the instance of the table. Now here, from here, how many super keys I got? 1, 2, 3, 4, 5 super keys we got. Now write, all of you give the heading candidate key. Give the heading candidate key. And write the definition. A candidate key is a minimal super key. A candidate key is a minimal super key. Minimal. A candidate key is a minimal super key. Now the thing is, what is a minimal super key? So candidate key is also a super key, but it is what type of super key? Minimal super key. What is the meaning of minimal super key? Minimal super key means the just write, all of you write. A minimal super key means the subsets of the super key are not a super key. The subset of that super key are not a super key. Let me show you. EMP ID, does it have, let me start with the this one. Okay. If it is a minimal super key, I will color it green. If it is not, I will color it red. EMP ID name department. What are the subsets of EMPID name department? What are the subsets? Subsets are subsets of this EMPID name department super key are EMPID itself. Next, EMPID name itself. Next, department itself. These are subsets. Then again, EMPID name itself. EMPID name, comma name. Next, EMPID department. And any other subset I have?
Ma'am, name department.
name.
Name department.
Name department. Name department. So these are the subsets. From first of all, you have to create the subsets. In order to find out whether it is minimum or not, you have to create the subset. After creating the subsets, what you will check is you will check among the subsets, is anybody a super key? If anyone you get as a super key, then you will say that this one is not a minimal super key. Here I can find out that EMPID is a super key, EMPID name is a super key. So many super keys I'm getting from the subsets. So what I will say that this is not a minimal super key. Now let us consider name department. Name department, when I break name department into its subsets, then what I get name as a super key. Name as a subset and department as a subset. Name is not a super key. I'm not getting name in this list. Department is also not a super key. Hence, I will say name, comma, department super key is a minimal super key. Okay. Next, EMPID department. When I break EMPID department into its subsets, I get EMPID as one of the subsets and department as the second subset. EMPID is a super key, so I will say this is not a minimal super key. EMPID name, again, when I break it, I get EMPID and name is the second subset. EMPID is already a super key, hence I will say EMPID name is not a minimal super key. And when it is a single attribute, no question of forming subsets. So I will say this is always minimal. So how many candidate keys did I get now? I got 2 candidate keys from the set of super keys. Candidate keys I got as this one and this one. Okay. So just write a line. There can be more than multiple candidate keys in a table. There can be multiple candidate keys in a table. And then primary key, which we already know what are the features. So these features are also candidate. Let me tell about this. Then I will say. Primary key is any candidate key. From the set of candidate keys, you choose any one as the primary key. Understood? From the set of candidate keys, you choose any one. The designer of the table will choose any one as the primary key. Only one. There is only one primary key in a table. So only one primary key is selected from the set of candidate key. So let us choose EMPID as the primary key. Now you will say, ma'am, why did you choose EMPID? There is no strict rule. You could have chosen name, comma, department as the primary key. No problem in that. No error will be there, or no, the design will be all right. But the thing is, there is the good design concept says that you should select that as the primary key, which has minimal number of attributes. First point. So here I can see that EMP-ID is having a single attribute. So I have directly chosen EMP-ID as the primary key. Now, another second point is you should choose such an attribute which doesn't change very often, whose values, like if you suppose you have phone number or address as one of the candidate key. Let us assume that address is also another candidate key. Now the question is, will you choose address as one of the candidate key? No, I will not choose, because good design doesn't say that, although it won't be wrong if I choose address, but address generally changes many times, isn't it? So try to select that candidate key as the primary key, which doesn't have a tendency of changing very often and which has minimal number of attributes. Combination attributes, maybe one of the attributes will change the value every time it is changing. So try to avoid that. Okay. Is it clear? Then I will stop the share and end meeting and we will reconnect. Is it clear? Super key, candidate key, primary key?
Yes, ma'am.
Everybody understood super key, candidate key? Because this candidate key is very important concept. Throughout normalization, I will be talking about candidate key. So you should understand this one. Minimal doesn't mean that a single attribute. Minimal means the subset of that super key shouldn't be a super key. Name department subsets, neither name is a super key nor department is a super key. Hence, it is a minimal super key. Now, if I ask you that every candidate key is a super key, but every super key is not a candidate key, will you be able to justify? Every candidate key is a super key. All these are super keys only because we have selected from the set of super keys. But all super keys are not candidate key because all super keys are not minimal. Here, similarly, can I say that all primary keys are candidate keys, but all candidate keys are not primary key? In other words, can I say that all primary keys are super keys, but all super keys are not primary keys? Okay, understood. All of you are paying attention.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Wherever you don't understand, ask carefully because I cannot see the participant list. I'm sharing the screen and I don't have time also to check what you are doing or whether each and every individual I can ask. So you should be concerned about whether if you don't understand, you will stop me and ask me. I'm ending this one. Reconnect again. Okay, let us start. So I will proceed now. I hope everybody understood. Now, write a problem. All of you give the heading functional dependencies and then write a problem. Functional dependencies, within bracket you write FDs. Let me write it. Just write it. Functional dependencies. Functional dependencies, and then within brackets you'll write FDs. Write a problem. Let us consider some suppliers are there. Some suppliers are there who supplies products to different cities. Some suppliers are there who supplies products to different cities. A supplier stays in a particular city. A supplier stays in a particular city. Every city has a particular status. Every city has a particular status. And a supplier supplies a particular product. A supplier supplies a particular product in a specific quantity. By a specific quantity. A supplier supplies a particular product by a specific quantity. Let me repeat. A supply, what did I say? Can anybody read?
Ma'am,
There
let
are
us
some suppliers who supplies products
to different cities.
to different cities. A supplier stays in a particular city. Every city has a particular status, and a supplier supplies a particular product by a specific quantity. Written?
Yes, ma'am.
Now, from here, if the problem is given to you, and if I ask you from the problem, you design the table and insert records according to the restrictions that are mentioned here. Now you will say, ma'am, what are the restrictions? I cannot understand. First of all, what is said there is every supplier supplies some product, isn't it? A supplier can write another line. A supplier can supply more than one product. A supplier can supply more than one product. Written? A supplier can supply more than one product, and every a product a product can be associated with multiple suppliers. A product can be sold by multiple suppliers. A product can be sold or supplied by multiple suppliers. Now, just listen, don't write. Till this it is written. Every supplier supplies multiple products, and a product can be supplied by multiple suppliers. It is written. Now listen. What is said in the problem, every supplier is associated with the city. City means where the person stays. Not that Not that 1 minute, my daughter. So the meaning is a supplier stays in a particular city. So if I say that S1 is a supplier, then S1 stays in, if I say S1 stays in Kolkata, then I will all S1 at a particular moment can stay only in one city. S1 cannot stay in more than one city. Okay. Every city has a status. The meaning is a particular status. The meaning is Kolkata. Suppose Kolkata is a metropolitan city. Okay. Or suppose we have another city where the population is very high. So status is given or a tag, it is a tag sort of thing. A status is given to every city. Whatever city I will write here, a status is assigned to those cities. Okay. And what is this quantity? What is PID? PID is the product ID. Every product has an ID. SID is the supplier ID. So every supplier is given a unique ID. That is the supplier ID. And every product is given a unique ID, which is the product ID. And quantity is what? A supplier supplies a product by a specific quantity, maybe 10 kg, 20 kg. So if I say the supplier supplies bread, then I will say supplier S1 supplies bread by this much kg. Okay. Now I will fill up the data according to the problem. So supplier S1. S1 is a supplier. Suppose the supplier supplies product P1. The supplier S1 stays in Kolkata, and the status of Kolkata is suppose K1, and the quantity supplier S1 supplying P1 by quantity 10. Maybe the unit, some unit is there. Next, supplier S1 also supplies another product, because a supplier can supply more than one product, isn't it? It is given in the problem. So this insertion is also all right. So supplier S1 supplies another product, stays where? Where does the supplier stay? Kolkata.
Kolkata.
What is the status of Kolkata? P1. How much quantity P2 is supplied? Maybe 12. S2 is another supplier, supplies product P1. A product can be supplied by multiple suppliers, isn't it? So P1 is a product which is supplied by S1, and P1 is a product which is supplied also by S2. S2 stays in Delhi. The status of Delhi is D1 and the quantity is 10. S2 only supplies one product. S3 is another supplier which supplies product P3, stays in Mumbai. The status of Mumbai is M1 and the quantity is 13. Let us take 14. S4. Achha, let us have only, let me give another. S4. S4 supplies product P1 again. S4 stays in Dhanbad and the status of Dhanbad is DD1 and quantity is 14 kg. Hey, why did you come there? আওয়াজ আসছে কি বলে? কি হলো, তুমি এখানে কেন? ওখানে যাও। Now, here, if I can you find any link between these attributes? Can I say one thing? Listen carefully. Can I say one thing that S1, the supplier S1, wherever I repeat S1, let me repeat S1 again once more. S1 also supplies product P4 and stays where? Where does S1 stay?
Kolkata, ma'am.
Kolkata.
Kolkata. What is the status of Kolkata? K1. And the quantity is suppose 16. So here, from here, just now you have said, ma'am, S1 stays in Kolkata, isn't it? So wherever S1 is repeated, listen carefully, please try to understand this one. Wherever S1 is repeated, the city of S1 is also same, isn't it? So S1 Kolkata, S1 Kolkata, S1 Kolkata. So can I insert any record where S1, I will once I have written Kolkata, and then I have written some other place, Dukkapur. Can I write this? Can I insert such records? I cannot. Why I cannot? Because a supplier stays in a particular city. The problem it is given. A supplier stays in a particular city. Hence, I can never write. And moreover, it is logically incorrect that the supplier, in the same instance, I am writing supplier stays in Kolkata and then I am writing supplier stays in Durgapur. So I cannot do this. Here, because in the problem it is mentioned that the supplier stays in a particular city. So wherever S1 is there, I have to repeat Kolkata. Moreover, wherever Kolkata is there, city has a particular status. It is written in the problem. So wherever Kolkata is there, I have to write K1, K1, K1. I can never write K1 here, and then I'm writing KK1. This is incorrect. Why? Because at a particular instance, Kolkata can have a single status. It cannot have multiple status. And in the problem, it is given that a city has a particular status. Here, so I am changing this to K1. Now see, whenever S1 P1 is supplying the quantity of product is how much? 10. S1 P1. Again, if I have S1 P1, suppose again I have S1 P1, I have to write 10. Though duplicate double is not allowed, so I'm not inserting that. So in the problem, it is given that a supplier supplies a particular, what is the meaning of the word particular? Means if the supplier supplies P1, P1 is a particular product supplied by the supplier S1. So S1 P1 will be associated with what kg? 10 kg. S1 P2 product is associated with 12 kg. So this is the relation. Keeping these relations in mind, can I say that city attributes or city values are dependent on SID? So wherever, when I'm inserting the city, I'm just checking that is this supplier present already? Like just now you saw that when I was inserting a new record, S1 P4, I just checked that where did S1 stay? Is S1 repeated above? Yes, S1 is present. So I found the city. Then I inserted Kolkata. Randomly, I did not insert any city. Isn't it? So there is a dependence of city attribute on the SID attribute. Moreover, suppose here S2 is not repeated. So let me add S2 again. Suppose S2 is the supplier who has now supplying. Previously, it was supplying P1 product. Now it is again updated itself and it is supplying P4 product. And when I insert this record, I always have to find out, is S2 present above in the above rows? Already it is present? Yes, it is already present. Hence, I have to check the city of S2. Only after checking the city, I have to add the same city. This is the dependence of city attribute on SID attribute. Wherever SID is same, city has to be same. Wherever SID is same, city has to be same. Again, similarly, wherever city is same, tuples where city is same, status has to be same. So this is also a dependence of status attribute on the city attribute. Here, this is also the dependence of city attribute, status attribute on the city attribute. Why? Because wherever I'm repeating Kolkata, if Kolkata is same here in these two tuples, then status also has to be same. Again, Delhi, these two tuples are same, hence these two tuples has to be same. Clear? So there is a dependence of status on city. And again, SID, PID, the problem it is given that a supplier supplies a particular product by a specific quantity. Hence, I will say quantity is dependent on how much quantity it will be is dependent on the combination of supplier and product. Okay, if P1 is 4, then the quantity can vary, but the quantity value is dependent on the combination of supplier and product. Here. So now what can I write is, I can write is 1. If I, what is the meaning of this one? S arrow Y. X is what? A set of attributes. Just 1 minute, please. Now, X to Y, X is a set of attributes, okay? Suppose X is a set of attributes. Set of attributes means it can have a single attribute or it can have multiple attributes. And Y is another set of attributes. Set of attributes, and of which relation? Of relation R. Then X arrow Y, the meaning is X determines Y. X determines Y. In other words, all of you write in your copy. X determines Y, or in other words, Y is dependent on X. Or in other words, Y is dependent on X. X is known as the determinant. X is known as the determinant. X is the determinant. Dependent variable. Dependent attribute. Whereas X is the determinant attribute. So Y's value is dependent on X's value. If X has same value in more than one tuple, then Y value has to be same. All of you write in your copy. X to Y, X arrow Y means X is the determinant, Y is the dependent. X is a set of attributes, Y is a set of attributes. Y is dependent on X means the value of Y is determined by the value of X. The value of Y is determined by the value of X. Writing, everyone is writing.
Yes, ma'am.
Yes, ma'am.
If two tuples in X, if two tuples in X has same value, then the value of Y should also be same. If two tuples of X has same value, then the value of Y also has to be same. Written? Now, from the table, it is clear, I already discussed that here, SID, can I write SID arrow city? Can I write? Wherever SID is same, city has to be same. Just write, wherever SID is same, city has to be same. Because city is dependent on SID. Because city is dependent on SID. Can I write city determines status? Wherever status, a city is same, status also has to be same. So status is value, status attributes value depends on city's value. Can I say that SID, comma, PID combination combinedly determines which one?
Quantity.
Quantity. Here, so SID determined city is known as an FD. This is an FD, functional dependency. What dependency? Functional dependency. City determined status is another functional dependency. And SID, PID combinedly determining quantity is the third functional dependency. So how many functional dependency we got from the problem? From where did I get these functional dependencies? The problem made us think about all these functional dependencies. So functional dependency is a restriction. Why restriction? Because if city is dependent on SID, the value of city randomly cannot be given. We have to think and we have to enter the value. So functional dependencies are also restrictions or dependencies that exist in your table. What is the need? We will know one by one. Now, whenever we write in this manner. We write in this manner. We write FDs of relation are set of FDs. Okay. So this is the first FD. First FD. This is the second FD. And we have three given FDs, but maybe we can derive some extra FDs. I will show you how. These are the three given FDs, or that we have found out directly. Directly we found these three FDs. It doesn't mean that we cannot have more FDs. Maybe there are some hidden FDs. We will apply some rule and we will try out. We will try to find out other FDs that may be present here. Now, let us do something to learn about some rules. Let us learn about some rules. What are the rules? It is known as axioms. Axioms. Some rules. What are the rules? I will tell you one by one. First rule is known as transitivity rule. Transitivity rule. See, everybody should pay your attention, Okay, because if you don't understand these classes, when I will teach normalization, you won't be able to understand. And I want everybody to understand carefully. Because if you don't follow today's class, again, I won't be repeating all these things and you won't get the. Okay, and be serious. Transitivity rules. I hope till this, is it clear? FDs? Any doubt in FDs? Till this, is it clear? Just
Yes, ma'am.
in your copy. All of you have written whatever I'm saying. Please take running notes, okay? Transitivity rule. Am I audible properly?
Yes, ma'am.
Who has unmuted? Everybody mute yourself. All of you mute yourself. Now, transitivity rule. What is the rule saying? The rule is saying. Now I will consider A, B, C, D. Okay, because every time writing these attributes is taking time. I will write A, B, C, D. Let us assume there is a relation R. There is a relation R, and the relation has attributes. Let us take 4 attributes: A, B, C, and D. These are the names of the attributes. Okay. Relation R is the name of the relation, A, B, C, D are the attributes. Now, what does transitivity rule say? Transitivity rule is saying that given A determines B and B determines C. These are given to you. These FDs for a particular relation R is given to you. Then you can derive a new relation, a new FD. Then we can say that A will also determine C. Just see. What is the transitivity rule saying? Transitivity rule is saying that suppose directly we saw that A is determining B, B is determining C. I can derive a new rule from there, a new FD from there by applying transitivity rule. And what is that new FD? That new FD is A will also determine C. Here, A to B, B to C. Then diagonally, if you just see this, then you will get A determines C. This is the transitive rule. Now, what is pseudo-transitive rule? 2. Pseudo-transitive rule says, pseudo-transitive rule is saying, given A is determining BC. Now, A is determining B and BC. Just 1 minute. What is it? 1 minute. A is determining B and BC is determining D. Yes, BC is determining D. Then we can say that A instead of B, A, C will also determine D. Just see. A given, what is given to you? 2 FDs are given to you. What is the 2 FDs? A is determining B is given and BC is determining D. Then instead of B, replace B with A and you will get AC will also determine D. Then we can blindly say that instead of B, if I replace B with A and then I will get AC determines D. See, there are a lot of proofs for this. You will say, ma'am, how did we get it? There are proofs. We are not going to do the proofs for this. So we will only know that this is what, if I apply pseudo-transitive rule, then I get if A determines B. So B is dependent on A And BC is determining D. D is dependent on BC. So what I will do, instead of B, I will replace B with A. So I get AC determines D. Will obviously, AC combination attribute will obviously determine D. This is your pseudo-transitive rule. Third one is reflexive rule. Reflexive rule, sometimes which is also known as trivial rule. Trivial rule. Reflexive. No, this is the spelling. Achha, reflexive rule says, see, every time I write in board now, A also determines C, then we will unite and we will say that A will also determine BC combination. Okay. Similarly, we have decomposition rule, the opposite of this one. If given A determines BC, then what? Then we will decompose. The rule name is decomposition. Decomposition. Then what we will say? We can say we will decompose and we will say A will determine B and A will also determine C individually. And the sixth rule is augmentation rule. Augmentation rule, suppose if augmentation rule is saying if A determines B is given to you or if B is given to you, then you can augment the other attributes both sides. So suppose C is another attribute which I can write AC, then AC will obviously determine BC. So I've augmented the third attribute C to both sides. Similarly, I could also augment AD determines AD will also determine BD. So this is known as augmentation. Any attribute can be augmented with the left side and the right side, and we can form a new FD.
Ma'am, ABCD are the attributes.
Attributes.
Ma'am, then what is the meaning of AB, BC, CD?
Now, AB means combination of these two attributes. Like if I say SID comma PID, determine, if I say SID comma PID determines quantity. Like here I have already written SID comma PID determines quantity. So this is A, this is B, this is C. Understood?
Yes, ma'am.
Understood? What is this AC together? AC together means one attribute is A, another attribute is C. They combinedly is determining BC combination. BC combination means what? B is one attribute, C is another attribute, their combination. Here A determines BC. This one, the meaning is A is an attribute which will determine BC combinedly. In other words, BC combination value is dependent on the value of A. If A attribute has same value in more than one tuples, then BC combination also will have same value. Okay. So just remember these rules so that we can apply it on when we will do some other. I'm stopping this.
No.
All of you give your attendance in the chat box. Last 2 digits. See, only 41 chats I got. It is showing me 51. Don't write present, ma'am. Don't only write the last 2-digit roll number, because once you write it in the chat box in the Zoom, it comes, all your chats comes in the Zoom folder. What I do is I take the roll number none and put it in the Excel. I sort it. Now, if you write present, ma'am, and all these things, then sorting becomes a problem. Again, everybody is writing present, ma'am, roll number. Okay, let me start. 47 participants. So, where is the doubt? Tell me. Till this, whatever I said, there you'll have a problem. Any problem or everything is a doubt? Hmm? Okay, if you understood all these things, then can anybody tell me if this is my relation? If this is my relation, supplier relation, and these are the given FDs, can you derive new FDs from here? Understood what I said? These are the given FDs, and your relation is this one. Can you derive new FDs from here?
Yes,
Am I
ma'am.
audible?
SID will derive
Yes,
status.
ma'am.
Tell me the rule and then say the FDs.
Ma'am, SID is dependent on status.
SID. Pupi, close the door. Pupi. Wait. Lot of noises. So what you have said?
Ma'am, SID arrow status.
SID, comma city to status.
Just see, my net is wait. My net, I have logged out from the other device. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
দরজাটা একটু লাগাও, খুবই আওয়াজ আসছে। না, একটু লাগাও। Okay, tell me, who was saying what are the new FPs that I will get after applying the axioms?
SID to status.
SID to status. How I will get SID to status?
Transitivity rule.
SID determines city, city determines status. So by applying transitive rule, we are going to get a new FD called SID determines status. What else?
SID comma city determines
city, comma status.
Wait. Let me write transitive rule. Transitive rule. Via transitive rule. What else?
Ma'am's SID determines city, comma status by union rule.
By which rule? City council
Union rule.
Acha. Okay. Try to,
Union rule.
whenever, yes, just let me tell you one thing. When I ask you that extend the FD, find out new FDs, don't try to combine FDs. Okay, union rule is there, okay, but try to avoid that union rule because when you unite them, then you cannot keep both. So try to avoid the union rule. You can write, no problem in that, but when any other FD you are getting,
Ma'am, reflexive rule. SID to SID.
you can write, no problem. Though the student who said me that SID will determine combination city, comma, status. We can add it. No issue with that. So by which rule? By union rule.
SID comma city determines status by
Union
pseudo transitive rule.
rule. Acha, pseudo transitive rule. What we are getting via pseudo transitive rule?
SID comma
SID?
city determines status.
SID comma city
Determines
determines
status.
status.
Yes, ma'am.
Let me check. SID comma city. SID to city. How we are getting pseudo transitive rule here? Can you explain?
देख के लग रहा था.
नहीं देखो SID to city, city to status is given to you. Okay, if it was something like this, SID to city and then city comma PID to status, then you could have written that instead of city I could have written SID PID to status. Okay, but this is not there. Combination attribute is not there. Only one attribute is there, so I won't be able to write that. If you check the pseudo transitive rule, A to B, BC to D. So this is a combination attribute. B is combined with some other attribute, then it is determining D. In that scenario, what we did is B is replaced by A and we get AC to D. But here it is not the same case. So this is not there. Anything else?
Ma'am, SID determines SID reflexive rule.
Reflexive rule. That is true for all the attributes. So reflexive rule is there. Reflexive. Anything else? Rule.
SID status determines city status.
Huh?
SID status determines city status by augmentation rule.
Augmentation rule. That's how augmentation rule is also there. So you can do that. Augmentation and trivial rules are many FDs you will get via augmentation and trivial rules. I'm not writing that. Anything else? Important one. Tell me, think about some.
CT and PID determines quantity. Pseudo transitive rule.
CT and PID. How?
SID determines CT, so we can replace
Whom you will replace?
Using number 1
No,
and 3
you cannot
statements.
replace. See, pseudo transitive rule is not clear to many of you. SID is determining city, SID PID to quantity. Now, if it was CT PID to quantity, then you could have replaced city with the left hand side. We can always replace it with left hand side. But here what we are getting? SID PID to quantity. SID is never determined by city, so I cannot replace SID with city. Got it? If it was city here, city comma PID, if it was city comma PID, then you could have replaced the left side of city. Who is the determinant of city? SID. But vice versa is not true. If SID PID is there, you cannot replace SID with city because city is a dependent variable. I cannot replace it with dependent variable. I always have to replace it with determinant. Like here in pseudo transitive rule, A determines B, BC determines D. So B was dependent variable. This dependent variable was replaced by the determinant, that is the left side. I can only replace it with determinant. I cannot replace it with dependent variable. Okay, think anything else?
Ma'am, SID PID determines SID.
Huh? Tell me.
Ma'am, SID PID determines SID.
Achha. SID PID by which rule?
Ma'am, reflexive rule.
Reflexive rule. SID PID determines SID. Reflexive rule already you said, but if I write this, then anything else I can write? SID PID determines SID. From this FD, can I generate new FDs? This is a very important reflexive rule. This particular reflexive rule. From here, let me tell you. From here, SID PID is determining SID. Can I write that since? Can I write this? Since SID PID SID PID is determining SID by a reflexive rule, and SID is determining city. So what can I say? Then by which rule? Transitive rule. What can I say?
SID and PID determine
SID PID determines city.
Yes, so by transitive rule, I can derive a new FD, which is a very important one. Why important? I will tell you not now. SID, PID determines city. I can write this. SID is determining city, SID PID is determining SID, and SID is determining city. So I can write a diagonal. If you think diagonally, then what I am getting, SID PID determines city. Isn't it? Everybody agrees with this FD?
Yes, ma'am.
Yes, ma'am.
Acha. Arekta bolo. This is a very important FD I got. Let me write one. Any other similar type of FDs? Just now I got SID to status, isn't it? SID to status.
yes, ma'am. SID and PID determine status.
Yes. By which rule? Same rule. Same way. So can I write that since SID, PID determines SID and SID determines status. Therefore, via transitive rule, we can have SID, PID will also determine status. Here, so SID PID is determining city, SID PID is determining status. Can I write another FD? Can I write SID PID will also determine SID. This is, so we have already written. We can also write SID PID will also determine PID by reflexive rule, and we can add another one which is already given. Another one which is already given, that is SID PID determines which one? Quantity. Here, from here, we got, by applying axioms, we got so many new FDs. From the FDs, new FDs, can I infer that SID PID combination? Listen carefully. Can I bring an inference? What is that? SID PID is such a combination which determines all the attributes of the relation. How many attributes are there? SID, PID, city, status, and quantity. 5 attributes. We just now saw SID, PID determines city, SID, PID determines status, SID, PID determines SID, SID, PID determines PID, and SID, PID determines quantity. So from here, can I say that SID, PID is such a combination, is a set of attributes, which determines all the attributes of the relation. Can I say this? If I can say this, now I will write since it is true, since this is true, so SID PID SID PID is a candidate key, of the relation. Any attribute or set of attributes which determines all the attributes of the relation is a candidate key. Or in other words, a candidate key, if it is a candidate key, then it should determine all the attributes of the relation. Right, everybody, right? This is a very, very, very important point. What you will write is a candidate key. First of all, we came to know a candidate key is a minimal super key. Now, another definition of candidate key is all these are valid. Okay. So another definition is a candidate key is a set of attributes which determines all the attributes of the relation. A candidate key is a set of attributes which determines all the attributes of the relation. So how did I, don't write now. How did I find out this? How did I find out that it determines all the attributes? By applying axioms. Now you might ask me that, ma'am, by applying axioms, we could have found some other candidate key. Yes, if there is, if your table contains more than one candidate key, by applying these axioms, you can find out some other attributes, maybe a single attribute or a combination attribute, which determines all the attributes of the relation. Suppose, for example, it is not true here. Suppose if you have SID is an attribute. Suppose SID is an attribute. Suppose SID is an attribute which is determining from, by applying axiom, you found that SID is determining all the attributes of the relation. Then you can conclude that SID is also a candidate key of the relation. Here. Now, here, when you found all these axioms you have applied, and one by one, you said me that now this is a new FD, this is another FD by union, this is third FD by augmentation rule. So collectively, when I collect them, I get a set of FDs, extensible set of FDs. That set of FDs is known as the closure of F. What is F? F is your given set of FD. What was your given set of FD? These three were your given set of FD, isn't it? Yes, this was your given set of FD. From this set, by applying the axioms, listen carefully, from this set, by applying the axioms, you have derived a lot of new FDs. All those set together, all those FDs forms a set, extensive set, exhaustive set in other words, and it is known as the closure of F. And what is this F? F is your given set. That means this is F. You write in this manner, F is equal to this one. So F is your given set of FDs. From the given set of FDs, you have applied the axioms and derived many new FDs. That total number of FDs might be given known as the closure of F. So here, all these FDs together, if you write in a set format, that is known as the closure of F. Closure of F. And how do I denote it? I denote it by using F plus. Plus will be as a superscript. Will be at the top. Okay, superscript. So, is it clear till now? What sort of things I said today? I said super key. What is a super key? I said what is a candidate key? How to form primary key from the candidate keys? Then I said what is a functional dependency? Then I gave you a problem of the supplier city status. From that, I made you understand about functional dependence and how to design functional dependencies from this supplier table. Who is dependent on whom? I explained those. And then I said you about how to form candidate keys from the closure of F. What is closure of F? And from the closure, I found an attribute which is determining all the attributes of the relation. And which one is that attribute? SID PID combination. I only got only one such combination which is determining all the attributes. I did not get any other such combinations from the F plus. So this table only has only one candidate key, and if a table has only one candidate key, that itself becomes the primary key. Because no option is there, only one candidate key means that is the primary key. Now you might ask me a question that, ma'am, closure, finding out closure is a very tedious job because there are lots of options, isn't it? And augmentation, so many augmentation new FDs I can find out, reflexive, so many. So it is very confusion is there. So whether you are able to find out all possible FDs or not. So there is another easy method to find out candidate key. Given a relation, if you are asked to find out the candidate keys of the relation, there are some other alternate ways. Maybe it is not easy. Maybe this method is easy for you. What is easy? That is the relative issue. Who finds easy in which approach? So I will next day, I will show you another 2 approaches for finding out candidate keys. Here, till this, any doubt? Please go through all these, whatever I taught today, go through these and then come prepared next day. Okay, come prepared next day. Otherwise, again, you will get confused. Whatever I said, and if you face any problem after reading whatever I told today, you can communicate with me. All of you are requested to make a group, WhatsApp group. Last time, I had created a group using the lateral entry students. So in that, it was a data structure group. Now you'll do one thing, any one of you take the responsibility to create a group, name the group as data structure, DBMS online, and add me and your friends there so that we can communicate if necessary. Don't do any unnecessary communication. Only if it is necessary, you can communicate with me. Okay. Yes or no?
Yep. Yes, ma'am.
Okay. And everybody go through whatever I said today. Go through your copy if you have written it properly. So I'm ending the meeting. Thank you, everyone.